Hi, good afternoon, everybody. Welcome to our natural science lesson 3 on digital school. So we're going to continue with the subatomic particles of um, an atom. So basically, an atom is made up of protons, neurons, and electrons. So at the end of this lesson, I'd like you to understand what subatomic particles mean, which is an electron, proton, and neuron, the subatomic structure, the composition of atoms, and the elements of the periodical table. So my computer keeps coming up with please move this window away from shared application, and I'm not sure what to do with that. So anyways, let's continue. The building blocks of matter are you're going to learn at the end of this lesson, the content, the building blocks of matter, subatomic particles, which are protons, neurons, and electrons. So in this lesson, you're actually going to understand what is, what a electron is, what a neutron is. And then I'm going to explain the composition of an atomic structure for some elements. And then we're going to go a little bit in greater detail about the periodical table and what the elements are. So the building blocks of matter is basically what atoms are. Atoms are the building blocks of matter. So atoms cannot be divided into smaller particles or destroyed in a chemical process. So atoms are made up of 3 different atomical particles, which are your protons, your neutrons, and your electrons. So if I make this diagram a little bit bigger, I'm going to show it to you and you'll be able to see it. So you have your protons and your neutrons that are in a nucleus, and then you have your electrons basically roaming around in each layer. It's actually sort of orbiting, but it doesn't orbit on its own and it's free. You know, like how in space, when you have all your planets, they each move around its own orbit. So just like here in this atom, each electron moves around an orbit, but in a specific manner, which I'll discuss a little bit later on with you. Now, the region of an atom is called the nucleus. So the nucleus is this part here, and the nucleus basically holds the protons and the electrons together. It keeps it compacted together. The nucleus is made up of positively charged particles called protons and neutrons. Yes, Michelle, can I help? You have a question? You can unmute. Michelle, can I?
عشان actually.
Teacher?
Teacher not
Michelle? Okay, what you can do is you can go to chat and then you can actually type in your question, and then I'd be able to answer you. And hello everybody, for those of you that joined a little bit late. Okay, so a nucleus, as I was saying, is that it is embedded in the protons and the electrons. You can go to chat and type in your question and I'd be able to answer it, okay? The nucleus is made up of positively charged particles called protons and neutral particles called neutrons. So that's again in this diagram so that you can visualize it and you can see it. So in this nucleus, you have the positively charged protons and then you have the neutrons. And now those protons and the neutrons, they work together. Now, the negatively charged particles called the electrons move around this, um, move around the orbit, right? And they move around in harmony with the protons. Now, atoms are neutral because you have a number of negatively charged particles, which are electrons, and it is neutral because it is equal to the number of positively charged particles, which are protons. So, for example, if you are holding an apple in your hand, in both hands, so say, for example, you have um, 5 apples in one hand, in your right hand, and then you have 5 apples in your left hand. So the number of apples in each hand are basically equal. So just like in an atom, the atom is neutral when we say that the negative charges, which are the electrons, equal to the positive charges, which are the protons. Now, if an atom gains or loses one or more electron, it is now called an ion. It is no longer an atom. It has a different name called an ion. So an ion is an atom with a net electrical charge due to the loss or gain of one or more electrons. Now, an ion would be discussed in another lesson. Our concentration in this lesson would be um, atoms and elements and how atoms, the composition of an atom. When you are missing an electron or two, you have a positive charge. And when you have an extra electron or two, you have a negative charge. Okay, so I would repeat that part as well. When you are missing an electron or two, you have a positive charge. And when you have an extra electron or two, you have a negative charge. So now I want to explain what protons are, what electrons are, and what neutrons are. So we have protons. Protons are deep inside an atom, and it is in a zone called the nucleus. The protons are said to be positively charged. Now you may ask yourself, what does this mean? What does it mean positively charged? Now to answer that question, we would think about the following phenomena that scientists have discovered. So when two protons get near each other, they push each other away. So like, let's say if we have two people with the same personality, like both of them are bossy. Now, because they are both alike and both of them want to have their own say, so they basically push each other away. Now, when an electron gets near a proton, now because they are different, one is an electron and one is a proton, they tend to attract each other. Two electrons will always push each other away, just like how in a proton, the protons are the same, they push each other away. Now also in an electron, because they are the same, they tend to push each other away. Now you may ask yourself, what causes this? Because why would protons push each other away and electrons attract each other? There must be some property of electrons and protons that make them apply these forces. So scientists use the word called charge. Now charge is used to represent the property these particles have. Now we observe that like charges repel each other. Repel means that the same charges pushes each other away, and opposite charges attract each other. So remember, just to recap on protons, we have protons, they are alike, so attract they repel each other. So like protons have like charges, they repel each other. Then we have an electron with a proton together. These are opposite charges. One is a positive and one is a negative. The proton is the positive, so P for positive, P for proton. And then we have the electron, which is negative. And these two attract each other. So if we had to move on, we go to in neutrons. So neutrons are particles that are neither positive nor are they negative. So this means that it is neutral. It does not have a positive charge, nor does it have a negative charge. The neutrons, together with the protons, form a tightly packed nucleus at the center of an atom. So just to illustrate and show you what this means is that these neutrons with the protons, um, they comprise, they are together. Like how we saw in a solid in yesterday's lesson, the particles of a solid were tightly packed together. So in this nucleus, we had the protons and the neutrons. They are tightly packed together. Um, so neutrons, now you can ask yourself, what's the function of the neutrons? Because basically you have a proton and you have an electron, and these two attract each other. Why must we have neutrons in the nucleus in an atom? So the function of a neutron, and it can also be a test question, would be a neutron stabilizes the nucleus. You can type in your answers on chat or your questions on chat, and I'll read through them and then I will answer them. Neutrons increases the separation between the protons, thus decreasing the repulsive forces between the protons. They also add to attractive forces between the protons and the electrons. So neutrons neutron stabilizes the nucleus. I'm going to repeat myself. So stabilizing the nucleus means that it makes the nucleus neutral. So it separates the protons. Now the protons in the nucleus, if you look at this diagram here, I will enlarge it for you. So the protons in the nucleus, they're all next to each other. And when they're next to each other, remember that I said that they tend to repel each other. So basically, the neutrons in there separate the protons from each other. So this decreases the repulsive forces between the protons. So that means that the protons won't repel each other all the time. And by doing this, it gives gives the protons a chance to attract the electrons, which are in the orbit around the nucleus. So the function of the nucleus is actually to stabilize the charges in the nucleus. So we'll move on to electrons. Electrons are the smallest of the three subatomic particles. So electrons are about 2,000 times smaller than the protons and the neutrons. Now, can you imagine that 2,000 times smaller? So if you can't really see a proton and a neutron, then it's going to be even more difficult to see an electron. So this is why in the previous lesson I said that the scientists have special microscopes to actually go in and study the structure of these neutrons and protons. Now, electrons move into a zone around the atomic nucleus at extremely high speeds, forming an electron cloud, which is much larger than the nucleus. And if we look at the drawing again, I'll make it bigger for you so you could see. So these electrons, they move around this nucleus at an extremely high speed. And because they're moving so fast, it forms a cloud around the nucleus. Now, it's very important that you understand, if we look at this box over here, that electrons do not orbit around the nucleus of an atom. Instead, they are electrostatically attracted to and mostly fixed in a fixed position to the positive charges in the nucleus and vibrate in that position. So basically what that means is, so if we have positive protons in the nucleus here, so for each proton, we have a an electron which is in the orbit, and they basically move in harmony with each other. Okay, so they moved in a fixed position around the nucleus. So each electron in here, each proton in here is moving in harmony with an um, electron that is outside of the nucleus. So it doesn't move freely, it cannot move freely, it's an order, and these basically forms your composition of your atomic structure. So if we go on to what an atomic structure is, so we have a particles. The particles are basically the proton, the neutron, and the electron. And then we have the charge. So the charge is, we have for a proton a positive charge and the symbol is a plus sign. So then we have the neutron. The neutron has no charge, which means that the symbol is just a capital letter N. And then we have an electron. The electron has negative charges and the symbol is E with a little minus at the top. Okay, I'm going to repeat, you are very welcome to type in your messages on chat, your questions, and I will respond to them. So the arrangement, an electron arrangement, I will explain here, is how electrons are arranged in atoms. So electrons move around orbits, move around. So move around means that it orbits. So another word for move around a circle is to orbit around. So electrons orbit around the nucleus. Now electrons do not randomly do this, as I said in the above slide. They orbit in a neatly arranged energy levels or shell. So each electron which is orbiting outside, they orbit in different energy levels. Now, each of these circles, you have the red one, the green one, and the yellow one. They are called your shells or your energy levels in which the electrons orbit. So this the red one, which surrounds the nucleus, is your first energy level. Then we have the green one, which is your second energy level or shell. And then we have the yellow shell, which is the highest, which is your third energy level. Right, and basically for this lesson, your highest energy level. So going into that in a deeper way, so we have an atomic structure. So electrons are arranged in energy levels or shells around a nucleus of an atom. Okay, so we have the first shell, which I explained earlier on. So this first shell here, so here you have your nucleus and your protons your neutrons and your protons in this nucleus. So the first shell here, it contains 2 electrons. Then we have the second shell here, and this second shell contains a maximum of 8 electrons. And in your third shell, it contains 8 electrons. Now, you can see there is a fourth shell here. Now, the fourth shell is um, not really for you right now, but it can hold up to electrons. Okay, so if we had to move on, we have atoms of an element. So we have, let's say, the element called helium, electrons in an atom. So it has an atomic mass of 4. So that means that there are 2 protons and 2 neutrons inside that nucleus. So elements are substances that made up of entirely one type of atom. Right, so helium has two um, 2 protons in it, which means that it would have also, who can tell me? If it has 2 protons, I want you to go on to chat and type in your answer. How many electrons would it have? Look, when you're going to write your answer, look at the answer and then type in your answer. How many electrons would it have? If it has an atomic number of 2 and the protons are 2, what would be the number of electrons? Can anybody tell me? Okay, so I'll move on. So hydrogen has, yes, I know you've raised your hand. Okay, so hydrogen has one proton and one electron. So the symbol for hydrogen is H. Okay, so what is the atomic number of hydrogen? So the atomic number of hydrogen um, would be 1. Okay, so let's look at the composition of hydrogen. So hydrogen, the symbol is H, the atomic number is 1. And hydrogen has one proton and it has one electron and it has no neutrons. So here inside it has one proton. So it does not have a neutron, mostly because it is not repelling against any other proton, so it doesn't need a neutron to prevent it from repelling against other protons. So if it has one proton, then the electron is 1. So you can see here on the side we have the electron, meaning it has one electron. So if we had to go to helium, we'll see how that atom is arranged. So we have helium, He, it's a capital letter H with a small letter E. So it has two protons in it and then two neutrons in it. And then around the orbit that orbits around it, it would have two electrons. Okay, so this this composition basically gives you an idea of how atoms are structured in an element. Remember yesterday, some of you still didn't understand what an atom was. Some of you did not understand what an atom was. So this gives you a better understanding of the composition of how atoms are made up. So in beryllium, we have it. If you look here at the symbol, it has the number 4. So this 4 means that it has 4 protons inside the nucleus, and with 4 protons, it comes with 4 neutrons. Remember, the neutrons there are preventing the protons from repelling against each other, and at the same time it's allowing the electrons outside to attract with the protons inside and to move in harmony. So these are you have 1, 2, 3, 4. You have 4 electrons. So in beryllium it has 4 electrons, 4 protons, and 5 neutrons. So the neutrons are a little bit extra because it softens the repulsion between the protons. You're welcome to type in your chat, your questions on chat, as I said earlier on. Okay, so we have the atom baron. So baron, it has 5 electrons, 5 protons, and 6 neutrons. So here you use your protons here, your electrons are outside, 1, 2, 3, 4, 5, and then neutrons are 6. We have the carbon atom. So this carbon atom, it has 6 electrons, 6 protons, and 6 neutrons. So in here, in your nucleus, you'd see your 6 protons, your neutrons are 6, and then orbiting around are your electrons. So it's 1, 2, 3, 4, 5, 6. Right, so we're going to move on to nitrogen. The nitrogen atom is 7. So we have nitrogen has 7 electrons, 7 protons, and 7 neutrons. So here's your protons, the black little marbles. The neutrons are your white marbles. and your electrons are the red marbles outside. So the color doesn't mean that that's the color of the atom. That is a specific color. We just put it in different colors for you so you can identify them. So an oxygen atom, the element oxygen has 8 electrons, 8 protons, and 8 neutrons. And this is basically how it is formed in your atom. So we have fluorine. So fluorine has 9 electrons, 9 protons, and 10 neutrons. So we have in here, again, our protons, we have our neutrons, and orbiting all around are your electrons. Right, so then the atom neon. Neon has the atomic number 10. Now, because it has an atomic number 10, it would mean that there are 10 protons inside the nucleus with 10 electrons outside of it. And it also has 10 neutrons. Okay, so I'm going to give you homework. Your homework would be to design your own atom. Now, this would give you the experience of knowing the composition of an atom and how the protons, the electrons, and the neutrons actually work. You know, when you do concrete work, it gives you a better understanding. So you are going to make a model of an atom using candy. So your materials that you would need basically 3 different types of candy or different colored candy. So depending on the element that you want to make, so if you're going to make some, like for example, let's say what I could say, this one. If we're going to make fluorine, you're not going to use 3 sweets. You're actually going to use 9. You're going to have 9 different types of sweets in composition of 9 electrons, 9 protons, and 10 neutrons. So you're going to need like basically a packet full of sweets. So this would give you an excuse to ask your parents to get you sweets. So, and then you can use it while you're studying because we all like to chew and eat while we studying. So there's 3, and then you're going to need a paper plate and a marker. If you do not have a marker, a pencil or a pen would do. So the method, step 1, you're going to go to the periodical table. I have one on the slide later on, and there was one on yesterday's lesson as well. And you're going to choose your element. Then step 2, you're going to divide the candy into 3 groups, depending on your into 3 groups, which is your electrons, your protons, and your neutrons. So the first group is your protons, the second one is your neutrons, and then the third one is your electrons. And step 3, I want you to draw a nucleus, and in the nucleus, you can place the number of sweets that comprises with your elements. So if you choose let's say if you choose helium, you will put in 2 protons, and then you put in 2 different neutrons, and then you're going to draw with your marker or your pencil outside more orbits. And in each orbit, you will put in the different amount of sweets depending on the element that you have chosen. Okay, so this is your homework activity. So what you're going to do is you're going to download this YouTube video, which you can do, and you can use it for learning purposes, and you can have your homework activity on it. It will give it to you. Or you can email me. At the end of the lesson, I will give you my email address, and I will send you these PowerPoint presentations so you can use it for study purposes. So in the periodic table, you have chemical symbols. So the chemical symbols are created with the name of each element. And usually if there is one sorry, there are usually one or two letters in a chemical symbol. The first letter of a chemical symbol is always capitalized, and then you have the second letter, which is in a lowercase. So if I show it to you here, you have the first letter is in capital letter, the second letter is in lowercase. Now this symbol AG is for silver, and it basically has 47 protons and 47 electrons that move around in its atom. The atomic number is 47. Right. So you have your periodical table. Now, remember in yesterday's lesson, we discussed Dalton's three postulates. Um, so now the three postulates, each element consists of indivisible minute particles called atoms. Indivisible meaning that it cannot be divided or by or made smaller by any means, which means that you cannot break it down. Okay, an atom is given an element. All atoms are in a given element are identical. That means they're the same. Like you have twins. Twins are basically identical twins. Identical twins look exactly alike. So in each element, every single atom is identically alike. Now, atoms also have different masses. So for each element in the periodic table, it has its own type of atom. The atom of different elements are different, and they have different number of protons. Right. All known elements are arranged in the periodical table of the elements in this manner. So we have the number of rows going from left to right, and these rows are called periods. So rows are the ones that move across horizontally, and they are called periods. And then we have columns, those are vertically, right? And these are called groups. Now they go from the top to bottom. So we have periods and groups. The elements are separated in the periodical table in four categories. So these four categories are known as metals, non-metals, semi-metals, and noble gases. Now semi-metals are called metalloids. And the elements of each periodical table will have a chemical number. So I'm going to show you a periodical table. So that now I put here, you have periods, they move, they are rows from left to right. So it goes from left to right. And then we have groups, it goes from the top to the bottom. And then here we have non-metals, metals, metalloids, and noble gases. So these are the four different types of elements that are made up of in this periodical table. So I want you to test yourself. You can either write it down or you can go to chats and type in your answers. I'm going to give you about 30 seconds to do that. You can choose an element. Wait, before we do that, what are the four categories that elements are separated into? So write down four different categories that elements are separated into. And then what do periods and groups refer to in the periodical table? So I want you to tell me, what do they refer to, the periods or the groups? You can write them down on a piece of paper. It will help you with your learning. If you're a little stuck, your answers are here at the top. Okay, so what I want you to do now for this your turn basically means that I want you to write down three elements that you remember from the periodical table and the atomic number. So you need to write down any three elements. You can use the elements that we discussed above, which was helium and fluorine and oxygen and hydrogen, and I think there were a few. So you're going to write the atomic number, and then you're going to write down the number of protons or electrons in a hydrogen atom. I want you to write the definition of what an atom is. I want you to define an element. Now, these two were from yesterday's lesson as well. I defined what an atom was, and I defined what an element was. And why do you need to learn the periodical table? So why do you think it is important? I did discuss that in yesterday's lesson. I want to see if you can remember that. So what I'm going to do while you are doing that is I'm going to look, I'm going to just flash these atoms for you so you can get an idea and do your own. So we have the helium atom. So while we have the hydrogen atom, we have the lithium atom, and we have the beryllium, we have boron, so we have carbon, we have nitrogen. So if you look here at the bottom of each slide, you have nitrogen has 7 electrons, 7 protons, and 7 neutrons. You get your answer from there. We have oxygen, we have fluorine, and neon. Okay, I'm going to put the slide of the periodical table in case you want to choose something else. So the atomic number of each above these symbols basically means how many protons there are in each of these elements. Okay, so remember, like for example, if I choose this one here where it says W. So if there's 74 protons, that means it must have 74 electrons. Okay, then this slide here, you need to learn this very, very well, especially for exam purposes. This is basically the elements in the periodical table, some of them, and what the elements names are. And in maybe next week's lesson, I'm going to give you a quiz on asking you to write down what these symbols are. Like, for example, I'll put in, maybe I should ask, I will write the symbol and you will write the name of the element. Okay, so that would be Tuesday's lesson. So I want you to learn the slide very well for Tuesday's lesson. You're welcome to take a screenshot of it, and while you lying down in bed or doing some exercise or whatever, you can learn it. Right. So basically, what I wanted you to learn in this lesson, atoms are made up of three different types of subatomic particles, which are the protons, the neutrons, and the electrons. Protons are deep inside the atom in a zone called the nucleus, and they are said to be positively charged. Neutrons are particles that are neither positively or negatively charged. They are neutral. So remember, neutrons are neutral. They do not have a positive charge, nor does it have a negative charge. Now, electrons are the smallest of the three subatomic particles. They have negative charges. So electrons, these move around the orbits of the nucleus, and they have negative charges, and they're the smallest of the three particles. Now, electrons are arranged in energy levels or shells around the nucleus of an atom. So this energy levels is where the electrons orbit around. Atoms make up elements and increase in atomic number in the periodical table. So all the atoms put together, they basically make up elements, and and it and in the periodical table, as each element atomic number increases, then that is how it is arranged in the periodical table. We have used some helpful links for you. You can go to the Maths Department of Education. You can type in Natural Science Grade 8 workbook, and you'll come up with this address here. And you have the workbook for the whole section of NASA materials here. Then some of the slides that I have made were derived from Danielle D. Van X, which she uses in her class when she teaches natural science. And then if you visit this link here, you would learn more about what an atom is. It's a really fun, cool link to visit. And it teaches you the basics of atoms. Our next lesson, which would be on Tuesday, we're going to learn about pure substances, which is elements and compounds, and how they mix with each other. Okay. And if you'd like more information, you're welcome to contact me on my email. This is my email address. It is ahafea@gmail.com. You're also welcome to download this YouTube video and go through it and use it for your learning purposes. I'm sure it would help you and benefit you. And you can follow us on social media at Teen Geeks, Africa Teen Geeks, at hashtag lockdown. It was a pleasure tutoring you. I hope you did benefit from this lesson. I really enjoyed tutoring you guys. And thank you so much. Goodbye. See you on Tuesday. Have a lovely weekend and use some of the time to study and learn because it will help you when you go back to school. Bye, people. Thank you.